Alright, let's do another limit example. Again, the limit of another rational function. Now remember, a rational function, I think of it as a ratio function. So there's a numerator and a denominator in a rational function. So let's have a look. Let's work out the limit of x tending towards -5 of x squared take 25 all over x plus 5. Alright, we notice that in the numerator we have the difference of two squares here. The first square being x squared and the second being 5 squared. So that means for us it's a quick and simple factorisation of the numerator. So let's factorise it and reevaluate. Because you'll notice at this point, if you plug in -5, so if we do a direct substitution of the numerator here, you're going to end up with a 0 numerator. And you're going to end up with what we call an indeterminate form. So that's 0 over 0, which is known as the indeterminate form. So, as I've said, you should directly substitute first, but if you get this indeterminate form, you realise you've got to do something more. You've got to do some more work. And the more work in this case is the factorisation. So let's do that. So you've got the limit, we want to reevaluate the limit as x tends to -5. Sorry, let's write it down here a bit better. Limit of x tends to -5 of x plus 5. Now this is the factorisation of the numerator I'm doing. X minus 5 all over the denominator of x plus 5. Alright, so what's our common factor here? We've got x plus 5 as a common factor, so that factor goes. And then we reevaluate the limit once we have eliminated this factor. So the limit as x tends to -5 of this function, you need to rewrite it out, notation is important. Don't be lazy, we have to rewrite it out. Equals -5 take 5 is -10. And that's the answer for the limit of this particular rational function. I hope that helped.